Okay, good morning, all. So today we are going to discuss a complete SQL Server architecture internals. Okay, so what is a SQL Server? How the SQL Server will behave here when you perform any transactions over the front end. Okay, front end is nothing but a client. Okay, so what are the key components are available when you go for SQL Server architecture? Okay, so that we are going to discuss relational engine, storage engine, a protocol layer, SQL OS, and also if we have the time, then we'll also cover the storages and page architecture. So how the data is residing in the SQL Server and in the form of pages. Okay, so what is the page architecture? Okay, how many types of pages are available? Each page we'll discuss individually. Okay, let me first. So as I told you, right, SQL Server will follows the client server architecture, correct? So there will be a client and there will be server. Okay, so whenever whoever trying to access the your database engine, okay, so database engine plays a key role in SQL Server architecture. When you especially go for SQL Server, so there are a lot many like integration service, reporting service, analysis service. We have another like a business intelligence services also available. But especially when you go to the Microsoft SQL Server, a database engine plays a key role. Like it is like a heart, okay, which can be control everything. You can do anything from the database engine service. Okay, SQL Server is a Microsoft RDBMS that works on the client server architecture. Here end user sends a request and the SQL Server accept a process and share the result with the user. Whenever you are sending any request, okay, whenever you are sending any request to the SQL Server, it's simple, very simple here. So when you try to connect to the any e-commerce applications like a Flipkart or Amazon or Snapdeal, okay, so when you are placing an order, you are sending one request, right? Somewhere your order need to be stored, right? So assume your Flipkart backend is SQL Server. Okay, front end is Flipkart, okay, which is developed by Java, .NET or PHP. So that is a client where you are trying to access the SQL Server. So when you open the Flipkart, when you try to log into the Flipkart with your credentials, okay, means you are sending the request, right? That username and password. In case when you are sending by entering your credentials, in case sometimes by wrongly you forget the password or you are passing invalid username or email address, you will get one pop-up, right? Invalid email address. Okay, yes or no?
Yes.
Yes. So whenever you are sending a request from the client, that can be, okay, tool, that can be application, that can be SQL Server Management Studio. So yesterday we have discussed, right? SQL Server Management Studio is the client tool, predefined client tool, which is provided by the Microsoft to access the database engine. Okay, sorry. Okay, so when you are sending any request, okay, so SQL Server need to accept it and process it and share the result with the user. So that is what happening. Okay, so this seems a very simple process from the front end. Okay, so what you will do every day, you will try to open the Facebook or Flipkart or Amazon. Okay, and you are placing the order, you are removing the order, you are deleting the order. Okay, you are cancel means deleting means canceling the order or updating your order, right? So from front end it is very, but when you go to the back end, when you go to the back end, the processing is bit complex. Okay, so whatever happening over the back end process, that may be bit complex when you are seeing from the front end. Okay, front end is very easy, but when you go to the back end, so lot many process are running. Okay, so that is what today we are going to cover. So what is happening when you send any request to the okay, so SQL Server in a simple diagram. Okay, let me discuss, we'll discuss in detail one by one in coming slides. Okay, when any end user, when any user uh, let me any user send a request, okay, that can be insert or update or delete or select. So these are the transactions mostly users will perform. Okay, either you are creating a request, you are placing a order, or you are updating the order, you are deleting the order, or you are seeing the tracking the order. Okay, so you can see like a tracking the order. Tracking is nothing but just checking where my current exact order is placed. Okay, either it is dispatched or packed or it is delivered for the out. Okay, so you can track, right? So these are the business transactions where everyone will perform. So when you are verifying, okay, first it will connect to the OS where your SQL server is hosted. Where your SQL server is hosted, somewhere it need to be hosted, right? Yes or no?
Yes.
Yes.
Yes or no, online people. Somewhere it need to, somewhere your either not only SQL, sir. When you go for Oracle, when you go for MySQL, any technology that need to be somewhere, it need to be hosted, right? First, it will connect to the operating system. First, it will connect to the operating system network. Via network. Once it connect to the operating system, so we will use different protocols. We'll discuss next slide. Okay. So we have TCP/IP, we have named pipes, we have shared memory. We have different protocols. Using protocols, TDS, tabular data structure. Okay, so using TDS, it will try to interact with our SQL server. It is a topmost explanation. We'll discuss in detail what are the key components. Next slides. Okay, so using TDS, it will try to connect to the SQL. So in SQL, we have main is database engine. Okay, so main is database engine. So when every operation you will connect with the database engine. So in database engine is only one key component which is processing our request. Okay, handling everything. So whatever you are performing on the SQL server, our database engine is a key component, like a main. Under database engine, again we have two more engines divided into two more engines. That is a relational engine, storage engine. Okay, so there are two sub engines in the database engine. So one is the relational engine, one is the storage engine. So whatever you are seeing here, okay, these three or comes into the relational engine. Okay, whatever you are seeing from bottom, so this all will comes under storage engine, like access method, buffer manager, buffer pool, plan cache, data cache, transaction manager, all will comes under storage engine where your data is residing. So relational engine is nothing but a parsing the query, preparing the execution plans. Okay, just it won't contains any data in when you go to the relational engine. Okay, so this is a brief about how your architecture looks like. So whenever you send any request, it will try to connect to the operating system using via network. Then it will try to interact with your SQL server to the database engine. First, it will connect to the database engine. Then it will start the processing your request. Okay, that can be insert, that can be update, that can be delete, that can be select. Clear overview how your SQL server architecture looks like internally. This overview, sir, we are not discussing in detail. We'll discuss in next slides.
Okay, sir.
So in
Any
relational
question?
engine, yeah,
Yes.
ODS will be the open data stream. So ODS will take the user queries.
Sorry.
In relational engine point of view, ODS will be the open data stream. So like TDS is nothing but SQL native client, right? So in relational engine point of view, ODS will be there. So ODS will take the user queries and send that query to storage engine, right?
Yes, here it will come, sir, under pressure. So
Okay,
in relational engine, just this it is a processing your request. Okay.
okay,
ODBC will work in access methods. Okay. So using access method, the relational engine and ODS using relational engine and storage engine will interact with each other.
okay.
Okay.
So
Yeah, good. Any other questions? Okay. So when you open the task manager, this is how your process is running. SQL serve.exe. Okay. And every like service will have the process ID. Okay. And the status whether it is running or stopped. Okay. So you will get the status. You can verify from the task manager. I will show you once we perform the SQL installation. Okay, so we'll discuss a lot about the SQL OS, not now. Okay, in the coming sessions, because before going to discuss SQL OS architecture, we must and should know about the processing, thread processing. So you must and should know about the processors, Newman node configuration, schedulers, workers. We have lot many key components. If you wanted to directly jump into SQL OS, now it is very hard to understood in the starting of your sessions. So once you are familiar with the SQL Server, we'll discuss a lot about the SQL OS architecture today as part of today's session. So we are strictly hard with the database engine and the relational engine and storage engine. So we have one more session. Okay, so on the complete about the SQL OS architecture, because on top of this layer, okay, on top of this layer, we have one operating call. We have one more architecture called SQL OS architecture. Nothing very simple. It is the one which is interacting with your Windows. Okay, SQL OS simply it is interacting with your Windows to process your request. Okay, so which is going to schedule your request. So whatever the request you are sending, that need to be scheduled and that need to be run, right? So that exactly that operation is working by the SQL OS. So on top of your database engine, so we have one more layer, sir, that is SQL OS architecture. We'll discuss a lot about SQL OS architecture in coming sessions. Okay, because first of all you should know what is the processor, what is the scheduler, okay, what is a worker, what is a task, everything. So that we'll discuss a lot. So no more question. Can I move to the next slide? If no
Yes.
questions, okay. So first let me discuss the network protocols. Okay, SNI SQL Server Network Interface. Okay, so SQL Server Network Interface is a network protocol layer to connect the database instance. Okay, just to wanted to if you wanted to connect to your SQL Server instance, so technically we'll call it as an instance. Every SQL, when you install the SQL Server on your laptop, that technically you need to call it as a instance. Okay, so every time when you perform the installation, that we'll call it as a instance. Okay, not only in SQL Server, when you go for Oracle, when you go for MySQL, when you go for DB2, mostly we'll call it as a instance. Even when you go for the cloud also, mostly the servers also will technically call it as a instance, EC2 instance. Okay, don't get confused. In when you go to the SQL Server, every installation, okay, you can perform multiple installations, sir. See, in my laptop, I having three instance, three SQL Server with the three different names. Okay, don't get confused. So you can install up to 50 times you can install your SQL Server in one mission. Okay, one mission. That can be logical, that can be physical. Max you can install 50. Okay, one is the default. That will discuss a lot about the instance concept. Okay, so mostly SNI SQL Server Network Interface will work to connect the database engine, to connect the database engine. So we have three protocols. So we have three protocols. Earlier we have four protocols, sir, like 4 to 5 years back. So we have four protocols. Now completely we are working with three protocols. One is shared memory, named pipes, TCP IP. One more feature is VIA, virtual interface adapter. Okay, that is duplicated. We are no more using VIA. We are currently using with the three protocols: shared memory, named pipes, and TCP/IP protocol. Okay, so everyone in the when you see the sorry when you see this peak, you will see the TDS, right? Tabular data structure. Okay, so tabular data stream is an application layer protocol used to transfer the data between the database server and a client. It was initially designed and developed by the Sybase. Okay, so as you know, right, SQL Server is purely developed by the Sybase. Okay, so developed by the Sybase. The advanced layer of Sybase is the SQL Server. Okay, so Microsoft has taken one key feature from the Sybase, that is TDS. So in when you go to the Sybase also, we are using TDS format to interact the data, to transfer the data between client and database. In our SQL Server also, we are using the TDS format. Okay, so for their Sybase SQL Server related engine is 1984. Okay, it is developed for Sybase. Same concept we are using in the SQL Server as well to interact the your client and server and to transfer the data between your client and server. To interact, to transfer the data from client and server. So we are using the tabular data stream. Okay, so currently we have three protocols, sir. One is shared memory, a TCP IP, and named pipes. So earlier, 5 to 6 years back, we have four protocols VIA. Okay, that is almost duplicated. So no more we are using. So we have only currently three protocols. Okay, clear everyone? So we'll discuss what is shared memory, what is named pipes, what is TCP IP.
Yes, yes, clear.
Okay, so when you go to the shared memory, when you go to TCP IP, when you go to named pipes, okay, a shared memory is a very simple, sir. When your client and server is hosting on the same mission, okay. See now, see in my laptop, okay, take in my laptop, see SQL Server Management Studio. Let me minimize this one. Okay, so SQL Server Management Studio is my client, and SQL is also installed in my laptop, right? So mostly it will interact with the shared memory. Shared memory is the simplest protocol and requires zero configuration, nothing. When your client and server is hosting on the same mission, then it will interact with the shared memory. It will interact with the shared memory. Got you? Okay, so no need any additional configuration. When you go for TCP IP, so TCP IP is the broadly used protocol, sir. Uh, in simple words, you are supporting from home, right? Everyone nowadays, everyone is working from home only, right?
Yeah.
Yes or no? So how you are supporting from home?
Uh,
Through network.
VIA, virtual
Through
network,
network. No, VIA. VIA is
virtual.
nothing but a okay. What's yeah, yes, okay. So you are connecting with the TCP IP protocol. Everyone is interacting with the TCP IP protocol. Okay, through network you are trying to connect. That means, sir, we required internet connection for the database server? No, sir. Okay, so to make a communication to the servers, you must and should require the internet. Okay, TCP IP is the mostly wide used protocol for the client and server connectivity. Okay, you need to enable the TCP IP protocol from the client SQL Server Configuration Manager. So this is, sir, so this is your SQL Server Configuration Manager, and expand the SQL Server network configuration, and just you need to enable it. We'll go for practical once we perform the SQL installation. Okay, so very interesting important question here is default protocol for TCP IP is 1433. A default SQL Server protocol support number is 1433. Okay, so the port number, default port number for TCP IP is 1433, and default port number for SQL Server is also 1433. Please try to make a note. Very important interview question. What is the default port number of SQL Server? 1433. Okay, so when you are going to install the SQL Server first time, so by default it will allocate 1433 port number. 1433 port number. Okay, so the default port number of SQL Server and default port number of TCP IP both are same. So 1433. Got you? Online people? Yeah.
Yes, Subbu, one question. So,
Yes.
for every application, are we going to change this default port number?
You can change it, sir. We can change it. Okay. But when you are going to install the SQL Server, by default it will create with the port number 1433. Later, once you perform the installation, we can change the port number.
No, I'm asking, see, in real time, whenever we are install for any client, no, so are we
Yes.
going to specify it particularly?
Yeah. Okay. From the real time perspective, that depends on your application. Okay, so in my previous project we will use 1433. Okay, in earlier project which I supported, that we will use a different port number. So they will specify every not only single application, sir, whole project they will maintain a unique port number, because Windows team need to enable the firewalls, right? So they need to allow the firewalls. If every application is maintaining a different port number, it's very complex to Windows team to maintain all the firewalls. So mostly at project level, they will maintain one unique port number. A whole project. See, one project we have multiple applications, sir. You see, if for example I'm working for HSBC Bank, assume in HSBC Bank I have multiple applications. Each application will maintain multiple servers. But I need to hand over to my application. Application is the application team is our primary contact, not our client. If you stuck somewhere, you don't directly call to HSBC. We will call to the application team owners. So based on your application team requirement, you can change the port number. But as a best practices, we never use 1433 port number in real world. Best practices. It is also one best practice.
Can we use the multiple ports?
No, sir. No. It will use only one port number. See, for example, please be mute. Okay, if you have two instances in one server, okay, see, in my laptop, I having three instances. Okay, three SQL Server instance. Okay, so can I use same port number for multiple instances? No, no. Within the server, no, sir. No.
Okay.
Okay, good questions.
So is it application team, right, who decides the port number, or Windows team?
Yes. No. Application teams. Windows team just they will install our servers and they will hand out to the us, as we are the DBS, right? So once
Yep.
we got server is built, then on top of that we'll install the SQL Server. So, but Windows team will enable all the firewalls. So they will maintain the standard port number for every database management system. When you go for Oracle, when you go for SQL Server, so they will have your client will provide the one default standard port number. So mostly in case if your application I don't want the standard port number, so I want my own port number, then you can interact with the Windows team to allow the port number. That again depends. See, some customers is very strict with their some policies, right? We need to listen the application team. So we are not like a right person where we can make a decisions. So application team is our primary person who can take the decision on our side, because we are just supporting the servers which for the current application. So application team is our primary contact. Without application team, don't perform any changes. Okay. So clear, everyone? So please try to remember. So default SQL number port number is 1433. Okay, this is one important interview question. Okay, so everyone clear? So we'll go for practical once you complete the SQL installation. So I will show you how each protocol I will disable, and I will show you the practical as well. Just concentrate on the theoretical part. Once you complete the installation, we'll go for practical. We are spending one whole day for the installation part. Okay, next we are one more protocol is named pipes. Okay, very simple. You know about the LAN cable, right? Everyone know about the LAN cable, right? Even when you purchasing a laptop and you're purchasing a desktop, you will have the LAN where you can plug in your LAN cable, right? So when your client and server is interacting with the LAN, okay, when your client and server is interacting with the LAN, then you must should enable the named pipes. You must should enable the named pipes. Okay, simple. When your client and server is interacting with the LAN, okay, network, then you must should enable the named pipes. Okay, mostly as a best practices, will disable the named pipes. Okay, so in case if application having some dependencies, then we will enable the named pipes. Mostly used wide protocol is TCP/IP, sir. Okay, when named pipes will be enabled means whenever the application having some dependencies, so they cannot directly use the TCP/IP to make an interaction between client and server. So then they will request, please enable the named pipes. Okay, so mostly as a best practice, we will use TCP/IP protocol, widely used protocol. Okay, so as per the application required, we can enable the named pipes, but when you are disabling named pipes, you must and should restart the SQL services to effect. Okay, that is also one key point. Please make a note. You must and should require downtime, sir. So don't call it as a restart, downtime. Please make some terminology. You must and should require downtime when you want to enable named pipes. Okay, after you enabling the named pipes, you need to restart the SQL services. Okay, means you require the downtime. So that can be 5 minutes, that can be 10 minutes.
So this downtime is for server itself, right? Not database
No,
server.
sir. No, sir. SQL server, sir. SQL
Okay.
services. We won't reboot the server. No need reboot the server. Just if you once you enable, go to the SQL services and you need to restart the SQL services. So we'll go for practical, but please make a note this point as well. If you wanted to enable TCP/IP or named pipes, especially we'll enable named pipes. If any dependencies for the application, in that cases, please make a note. You must and should require the downtime. So hardly my best practices take 30 minutes downtime. Okay, but it requires only just 5 minutes only. But as a safe side, we need to be safe as a DBS. Take 30 minutes downtime. Okay, because sometimes after you enabling, if you restart the SQL services, if SQL service is not coming to online, then gone. Okay, so in that so that is why please take downtime for 30 minutes. Ask application team to enable the TCP named pipes. We require the downtime, so please provide your uh, uh, schedule time, so when we need to perform this activity. Okay, don't see our Indian time, sir, your client time. So you need to see your client time when your servers are, where your servers are hosted, like a CST or EST or PST or okay. So please maintain your server downtime, not our local downtime. You need to convert. Okay, so any questions over network protocols? So when you are trying to interact with the LAN cable, then you will enable the named bus. Next, one more concept is VIA. Okay, virtual interface adapter. Earlier, sir, like 5 to 6 years back, like 2005, 2000, we are using VIA concept where whenever you are interacting your client and server via Wi-Fi. Okay, so when you are interacting your client and server with Wi-Fi, then we require the VIA feature. So that no more we are using, but try to remember if someone is asking what is VIA, virtual interface adapter. So when we are interacting when your client and server is interacting with Wi-Fi, then you must and should require VIA protocol. But no more is we are using, that is completely duplicated. So if someone is that, then you
We
will
are
get one doubt.
using.
Oh,
We are using
okay. Who is that? Who is
Manoj.
Manoj? Okay, very good. So which version?
It's I don't know version, but yeah, we use that to connect to our client network.
Okay, okay. So yeah, Manoj telling yes. See, that's what. But nowadays, no more everyone using VA. Very lesser, because even Microsoft is also stopped the support for older versions like 2000, 2005, 2008, 2008 R2. Now no more is we are using. Okay, but still some application, okay, are using 2000, 2005. But sir, something different when you go for 2000, sir. 2005 onwards, you will not face much complex. Okay, but on 2000 you see some complex when you wanted to access the SQL Server, when you are dealing with a SQL Server on 2000 version. I can share you the links from SQL 2002 2019. You can download everything. I will share you one uh, Google Drive link. You can download everything and you can play with the SQL service. That is your server. You can play with on your servers, but don't play everything on production box. Okay, please be careful. Okay, so clear everyone? Network concept.
Yes.
Any questions?
No, sir.
Okay, yeah, good. Now, so now let me discuss about the database engine. Under database engine, we have the key component like relational engine, right? Yes, let me discuss. So database engine is the core of SQL Server architecture. Okay, this provides the layer between your client connecting using the available protocols and the SQL OS, the core internals. Okay, so SQL OS is also plays a key role. Okay, we'll discuss a lot in the coming days about the SQL OS. Okay, very interesting concept, very complex concept. Okay, but as a DPS, we must and should know about the complete about SQL OS architecture, what exactly SQL OS is performing. We'll discuss lots, sir. As of now, no need to worry. Okay, so database engine requires the logical architecture of SQL Server, which contains of or work with physical architecture, the relational engine to execute the user request. In a simple words, okay, when user is sending any request, when user is sending any request, the query processing, okay, transaction processing, okay, security processing, everything will be done under the database engine. Okay, database engine is complete a physical, assume it is a physical. In physical we have logical like a relational engine and storage engine. Okay, so relational engine will process your request. What exactly it will process? Okay, what exactly it will process means it will have three components. One is command parser, query optimizer, query executor. So these are the three key components in the relational engine. When you specially go to the relational engine, so there are three components. One is command parser, one is query optimizer, and query executor. So when you go to the relational engine, these are the three key components. So for example, let me see. So for example, I am performing, okay, select star from EMP. Okay, I'm retrieving the data of employee data. Okay, employee is my table, sir. Okay, employee is my table where I wanted to see the data, what data is available in the employee table. I am just executing a query, select a star from EMP. Okay, so whoever know about nothing about queries, no worries, we have the development session. So I will explain you what are the objects, how to perform a basic commands. Not I am not digging inside as a developer. As a developers, what they will perform, what type of queries they will triggers. Okay, so what are the objects you can create at the database level? Because even you are a DBA, even you are a core DBA, you must and should have a basic knowledge on development, because we need to work on the performance tuning. When you start working on the performance tuning, we need to analyze the what type of request the application team is triggering. Either it can be select or business transaction like insert, update, delete, or they are running any stored procedure. So we'll discuss about in development session a basic what kind of objects, so how what are the syntax they will follow, what exactly developers will do on the developer side. We'll discuss lots, sir. Just I am retrieving a data, select a star from EMP. When I am performing this operation, what exactly internally will happen? So once it passes from okay, database engine to relational engine. In relational engine, we have the sub components like a command parser, query optimizer, query executor. Okay, so your command parser which parse the request, okay, means which will check the syntax error. So in case you are passing a right syntax. So for example, see, when you are applying any form in the front end, okay, when you are applying any government job, so when you are filling any form on online portal, Sometimes by mistakenly you have entered a invalid email address, so you will get one pop-up, right? Invalid email address means valid parsing, it need to be parsed. So that kind of parser can be done in the backend. Syntax error. So parser is the general terms which means the transforming from one language to another language. See, it is a high level language, sir. Select star from is a high level language. Your command parser will parse into the low level language as well, which can be understandable by mission level language. So high level language to mission level language so that it can be understandable. Okay. Along with the syntax check, it is also we have one key component called algebraize. Okay. So it will check whatever the whatever the query you are processing, right? That query, how many objects are available, it will verify all the objects and it will bind them. Or that bind we are telling, technically we are telling as a query tree. So whatever the syntax, whatever the statement you are passing, that will first check the syntax error and it will bind and it will prepare the query tree from high level language to low level language. Got you, online people?
Yes.
So high level language to low level language. Once the query tree is generated, also here one let me explain after. Okay, let me go to the next slide. No, not here. Okay, next, optimizer. Once your query tree is prepared, then it will go to the optimizer. Okay, sir, I am telling only 5 minutes here. Optimizer is a heart for SQL Server. Okay, like it is a heart. Optimizer plays a key role. Okay, I'm just giving only 5 minutes to 5 to 10 minutes here. We have separate session for optimizer. Okay, like which I need to cover like a 1 to 2 hours. We'll discuss a lot on optimizer, sir, because this is the key component in the data relational engine. In when you go for database architecture, SQL Server architecture, optimizer is the one of the key topmost concept where we need to discuss a lot, because optimizer prepares the plan, execution plan. So based on the cost, based on the selectivity, based on the cost, based on the selectivity, based on the stats, it will prepare one plan for everyone understandable. Okay, assume your family members are planning a tour. Yes or no? For you thought that you need to plan a tour for certain place. You will start preparing the plan, right? Yes or no? In a simple understanding, sir, everyone. So for
Yes.
example, your family decide to a tour, and you will start preparing the plan, right? So whether we have multiple plans, so either you can go for roadways, either you can go for airways. Okay, in roadways again we have multiple option, either you can book your own cab. Okay, or you can go public transport. So multiple ways, right? You need to see the budget, you need to see the members, you need to see the budget, right? Yes or no? Two key components here, members and budget. Yes or no, online people?
Yes.
Yes.
Like same, when you performing any operation in SQL Server, optimizer will see data, how much data and what is the cost. When our point of view, cost is money, sir. Simple, cost is money. When you go to the SQL point of view, cost is like a CPU, memory, IO. When our point of view, the cost is simply money. Okay, but when you go to the SQL point of view, the cost is nothing but CPU, memory, IO. Okay, so optimizer is a cost based process where the optimizer choose the least costly plan. Okay, so it will verify the CPU, it will verify memory, it will verify IO. The cost factor is not based on the time but on the resource consumption via memory requirement, CPU usage, and no of input output. Okay, so optimizer will prepare the plan for you, a execution plan. Okay, in a simple way, execution plan. So that is what we have a separate session. I cannot tell you in a 5 to 10 minutes. It is not a best. So optimizer we need to spend at least for 2 to 3 hours. Okay, so that is why we have one more session, sir, where we will discuss in detail how the optimizer will prepare the execution plan. Technically, like a technical words, cardinality estimation. Estimate, it will estimate how many records are need to process. Based on that, how many records we are selecting. Based on that, it will see the cost, how much memory I need to allocate, how much CPU I need to allocate, how many IOPS will perform. Then it will start preparing the plan. From our point of view, money, from SQL point of view, CPU, memory, IO is the cost. Everyone clear? Basic, sir. Okay, I am not digging lot. Okay, we'll dig lot on the troubleshooting. Okay, in advanced level, we'll discuss lot about optimizer. Again, I will come up with the optimizer concept in advanced performance training. Clear? Not clear?
Yes, yeah.
Any questions? So make a note, sir. When you are discussing SQL Server architecture, optimizer is the topmost. Okay, where you need to spend some time when you are explaining the SQL Server architecture over the interview. Okay, so
One
optimizer
of the
having,
main parameters is statistics.
yes,
Statistics,
update
right?
statistics. Yes, sir,
Yeah,
update statistics. Yeah,
yeah, the statistics. Yes.
yeah, update statistics. Because a lot many concepts are we need to discuss, like stats, cardinality estimation. Because before 2014 we have one cardinality estimation. After 2014 onwards, since 2014 onwards, Microsoft is upgraded the cardinality estimation. So we have lot many parameters where we need to discuss from the optimizer point of view. We need to know about how to read the execution plan, how many ways we can read the execution plan. So what are the operators, their cost, lot many, sir. So that is why I am not discussing a lot about optimizer now. We'll discuss in advanced performance tuning. It's a simple idea. So optimizer will prepare the execution plan based on the selectivity, based on the cost, based on the stats. Say cost based. Okay. Clear?
Clear?
Not clear?
Not clear? Yeah, clear.
Any questions, online people?
No.
Okay. So once your plan is prepared, once your execution plan is prepared, sir, let me tell you one point. Okay. Let me go to the again back side. Okay. So we have plan caches, sir. Okay. So we have plan cache in the storage engine. Okay, when you go to the storage engine concept, we have plan cache. So whenever you are assume you are trying to execute the first time, select star from emp. First SQL server will check any plan is available in the plan cache. Okay, so your command parser will check the any plan is available in the plan cache. In case there is no plan, okay, then it will start the preparing the execution plan. Okay, if so, for example, today I executed select star from emp. So SQL server prepare one plan. That plan will be temporarily stored in the plan cache. That plan temporarily will store in the plan cache. If tomorrow I am executing the same select statement without any changes, sir, without any changes means you need to see the spaces as well. Without any changes, if you are running the same select statement, okay, it will use the same plan which is available in the plan cache. That is also one key factor everyone need to remember. Your command parser will parse the request, along with it will also check any plan is available in the plan cache. Okay, got it? See, your command parser is coming to the access method. See, your command parser is coming to the access method and you will check the any plan is available for this request. If no plan, sir, it will start processing the regular way. If plan is available, then again no need to prepare any plan, it will use the same plan. Okay,
So here the query or let's say request should be the same, right?
yes, sir. That can be any user, sir, that can be any user, but the query, the see, so for example, today Manoj executed select star from MP. Tomorrow Raju is executing select star from MP. Sir, again it will prepare the no, sir. the request. So whatever the transaction, whatever the query you are triggering over to the database engine, that should be same. Who are performing, that's not matter. Okay. Clear? Not clear?
So one question here. So optimizer will work based on a cost-based, right? So if it
Yes.
is so first time you are inserting or deleting or any other statement, first time it has to create the plan, right?
Yes.
So how it will compare whether if it is only creating a one plan, so how it will decide whether it is a cost based or any, it has no other plans, right? So it will create multiple plans or any other only one
No,
plan.
it will see, not one plan, it will create the multiple plans internally. Okay, so we need to discuss a lot about the update statistics center. Okay, if you need to be strong at optimizer, we need to know about the stats, update statistics. So update statistics is the backbone for the optimizer. Okay,
Mhm.
so update statistics is the backbone. So update statistics need to be up to date to the optimizer so that your optimizer starts preparing the plans. So once it prepared the plan, then it will choose the best plan. Okay.
So okay, so if you are in if you are querying any statement, it will create a multiple plans, right?
Yes. Yes.
Okay. Okay, that's
See see, let me I can show you practically in query store. Okay, we can forcefully tell to SQL. Okay, we can forcefully tell to SQL, hey, don't use this plan, use my plan. Means that means we SQL is creating multiple plans, right? We are
yes.
telling to the SQL, hey, use this plan, don't use the earlier plan. So we can tell SQL forcefully to use my plan when you are triggering this request. Okay,
Okay.
that also will go for practical in advanced performance tuning in query store, so which is introduced on 2016, Anita.
So okay, we cannot give any. We can select the query. I mean, we can select the plan which you SQL wants to execute. We have an option for that.
Yes, yes, yes.
Okay.
Not first time,
Normally.
not first time, not first time. Okay,
Okay.
once it start preparing, we have certain parameters like a query store where we can forcefully tell to SQL server.
Okay.
So basically, when you're firing first time means overall the database memory level. First time, if when somebody is firing a query, it will check whether the any plan is there for that query. If it is there, it will use. Otherwise, it is going to create.
Yes, sir. Yes, sir.
So, yeah.
Yes, Murli.
So, yeah.
See, first time we do know, right?
Second thing I understood. No, similarly, second thing, sometimes the same query plan may change based on the IO. So during that time, you may not be going to be happy. So when the old plan is happy, then you are going to fix it. Use this plan
See,
only for all the
let me give you one example, okay?
yeah.
Please be mute, okay? I'm getting some echo. See, let me give you. Uh, let me take one application. So my previously that application is running on 2008 R2. Okay, so I'm having one database and on SQL Server 2008, and a user is upgraded to 2014, 2016, 2017, 2018, 19. Sorry, 19. Same database, same data, so same structure, same infrastructure, but the SQL version is different. While you are executing this over latest versions, because completely the optimizer is updated, then SQL Server will start the different plan with the same object, same data, because the cardinality estimation is different. Yes or no? Like SQL Server will start the preparing based on the stats. Your stats are updating, right? So every time, that is what backend, there is a backbone for optimizer is a statser. Every time you need to update the stats. If your stats are not updating up to date, your optimizer will choose the plan which is available. Every time your stats need to be updated means we need to tell to see you created one table today. Today you created one table and you inserted 1,000 records. You perform select star from EMP. So your optimizer prepares one plan. After 10 days, you inserted one core records into the table. Now, how many records are available in the table?
1,000 only. Stats
No.
as per the stats is 1,000.
As per the
Table has
optimizer 1,000, as per table itself, it having one core record.
yes.
So we need to especially tell. Please be mute. I am getting some echo. Okay. See, we need to update to the optimizer so that optimizer starts preparing the new plans. If you are not updating the optimizer will choose okay, whatever the plan is available, whatever the data to the optimizer, then it will choose the same. That will again impact the performance. So that is what we'll discuss a lot about the optimizer in advanced performance tuning level. So stats, coordinate estimation, legacy coordinate estimation, force query plan, okay, each operator cost. We'll see all these parameters, key parameters in the tuning level. Okay. Questions? Comfortable?
Yes.
Okay. Next, once the optimizer done, okay, then query executor. See, there is no more data physical. Okay, so it's a logically your processing, query processing will be done in the relational engine. So complete your data will be residing on the your data will be processed under a storage engine, sir. So your query executor, okay, calls the access method. Okay, it will call the access method, which is part of the storage engine. Okay, so access method is the key component in the storage engine. Okay, so your executor will request to the access method contains multiple APIs, application programming interface. Your access method contain multiple APIs, like API stands for application programming interface, where it can be understood what you are performing exactly. Either you are performing DRL, data retrieval transactions, or you are performing non-select like DDL or DML, like creating the objects or performing any manipulations like insert, update, delete. So it acts as an interface between the query executor and buffer manager. Okay, so buffer manager is nothing but your RAM, sir. Exactly, your RAM. Okay, in top of your RAM, so it is creating a buffer manager. Okay, all your transactions, so whatever you are performing, it will done, okay, over the buffer. You are not directly performing anything over the databases. Either it can be select, either it can be insert, either it can be update or delete, anything it is going to perform in the RAM. So memory will plays a key role when especially working with the SQL Server Management Studio. Okay, see, storage engine contains the physical database architecture along with the access and the buffer manager. Okay, buffer manager is the key component in a storage engine, plays a major role plays a major role. Your storage engine is responsible for physically data storing and accessing, and when it needed, when it wanted to access, when it wanted to process your data, everything will be done in the storage engine, under storage engine. So buffer manager is the key component. Okay, so physically database architecture is described. Okay, let me erase this content. Okay, so physical database architecture is described of how actual data is storing in SQL Server. So that is having two layers, sir. One is physically your data is residing in files. Okay, so let me show you one pic. Yeah, your data is residing in the file, sir. .mdf. Okay, so master data file. We'll discuss a lot. Okay, so physically when you go to where our data is residing means physically it is residing in the files. .mdf. .ndf. Okay, logically your data is residing under the also residing under buffer manager. Logically it is residing on the buffer manager when you are processing any request, but physically your data is residing under the files. Physically it is residing on the files. Got you, online people? So logically, you are performing everything under buffer manager, but physically your data is residing under files, database files. Online people, clear? So when you create any database, by default it will create the files. We'll discuss a lot. Okay, after this we'll discuss about the database files only. Just hold for a while. Okay, so in when your executor, query executor sent a request to the access method, so we are performing two types of transactions, sir. Okay, one is DRL, one is non, like any DML or DDL, like a create, alter, truncate, drop, or you are performing, or insert, update, or deeper performing. What commands you are performing, based on that your access method will works. Okay, your access method will works. Depends on the request. Depends on the request. What request we are performing. So your access method will work accordingly. Okay. Let me give you one more point, sir. So next 2 days is interconnection link. Uh, Whoever listening the first time, definitely you have lot many doubts. Okay, so please be hold for next 2 days. We have continuous sessions, right? So there is dependency features where you need to know how the data is processing internally. It's completely internal, sir, how data is processing. Whenever we are sending any request, how the data is moving physically, how it is again coming to the logical, and getting the data to the end users. Everyone will having some doubts. Okay, please be hold for next 2 sessions, then you will get one complete end-to-end picture what is happening over the back end. Okay, okay, see, okay, so when this is assume this is your buffer manager. Okay, buffer manager, when your SQL server is boosting. See, whenever your operating system is restarted, okay, so when your operating system is coming online, so your SQL OS will allocate a buffer manager. Your SQL server OS will allocate a buffer manager. In that buffer manager, we have the pools, buffer pools. Okay, in the buffer pools, we have the caches, like a temporary caches. Okay, like a plan cache, log cache. Okay, so you can go to the bank, sir. Take example bank. So when you go to the bank, every cashier will maintain the temporary cashier, right? Yes or no? When you go to 430 bank, when you going to the closing period, so they are moving the data amount which is available on the cashier to the main locker. Yes or no? Online people. Hello.
Yes.
Yes, right. Like same, sir. Okay. When you go to the SQL also, SQL will have the caches. SQL will have the caches. Once whatever your transactions you are performing, it will keep, okay, that amount of data in the cache for temporary, because when compared to storage, memory is much faster. When compared to storage, memory will much faster. So SQL server will keep whatever the transactions we are performing, like insert or update or delete, everything will be processed cache under the cache. Okay, okay, clear.
Yes.
So that's what, please be hold. Okay, so we have lot many things need to be discussed. Okay, when you are performing select operation, when you are performing any create or insert or update or delete, okay, so your access method sends a request to the buffer manager. So first it will verify. So here the data cache is the main, sir. Data cache is the main key component here. Okay, so whatever the object, so for example you are performing select star from emp employee table, first it will comes to the data cache, and it will verify any data is available in the data cache for respect to object. So what exactly it will do, sir? Storage engine means first it will go to the data cache, and it will verify any data available in the data cache to respect to query, means object, whatever you are performing, right? Select star from emp. So in case your data is available in the data cache, Okay, so it won't again go to the physical. It again won't go to the physical. It will directly send the data from the data cache to the end user. If no data is available in the data cache on respect to object, it will get the data from the physical and it will place one copy in logical in the data cache and it will send data to the requester. This is what happening in the backend, sir. Okay, when you are sending any request, first it will go to the data cache and it will verify any pages, any data is available to respect to query in the data cache. If it is available, then it will send data to the end user without going and getting the data from physically. If no data is available in the data cache, it will get the data from physically and it will store the data in temporarily in the data cache and it will send data to the end users. So this is what happening in the backend. Got you? Please hold, sir. That is what I told you, right? Next two sessions are dependency sessions. We have lot many doubts. You need to know about what is the physically where the data is residing, how data is storing in SQL Server, how the data is transferring. Okay, hold for next 2 days. Any questions? Clear? Not clear?
Yes, sir.
Any questions remaining, people? Okay, just hold, sir. Next 2 sessions, you will get one complete picture of the backend. I am not discussing anything over the front end. We are completely discussing next 2 days completely backend. So what's going wrong? What's happening over the backend when you are triggering any request? So these many activities are performing, sir. You are just placing a order in the front end. You are just placing a order in the front end. You are updating order in front end. You are deleting the. You are canceling your order in front end. Okay, you are tracking your order in front end. These many things are happening over the backend. Your requests, your transactions and processing, these many activities will perform in a fraction of seconds. Okay, clear? Not clear? We'll discuss lots, sir, about the data cache, about the physical. You need to know about the how the data is residing in the database first of all. So that is what all 3 sessions. First 3 sessions are the dependency sessions, sir. Once you complete the 3 sessions, you will get one complete idea how data is processing internally, how data is storing, how data is processing. Any questions?
So the relation engine will interact with storage engine. Only DB, right?
Yeah, your relational engine, your query executor will send request to the access method, sir. Access method is part of the storage engine. Your access method will verify what transactions you are performing, like whether you are performing the DRL, whether you are performing DDL and DML. Okay, mostly these are the business transactions will perform based on the request. Based on the request, your storage engine will act. Either you are performing
Okay.
data retrieval or you are trying to insert or update or delete. So that is what we'll discuss in next session, very detailed. Before that, you need to know about how the data is storing the SQL Server.
Okay.
Okay.
Good. Thank you.
See, buffer manager is the one of the critical aspects in the database system performance. Any user request or a data processing cannot work directly on the storage. You are not working directly on the databases. Means you are not working anything on the physical directly. You are completely working on the logically. Logical is nothing but your storage engine. Storage engine is completely logical. Physically, your data is storing in a disk, sir. Physically, your data is storing on the disk in the form of files. Okay, but logically you are performing everything in the buffer manager, in the RAM. Logical, everything logical, sir. Okay, finally your data will be moved into the physical. That is nothing but files. What kind of files? That we are going to discuss. The first time, whoever seeing the first time, you will have few questions. next 2 days we'll clarify all the questions, sir. How the processing, how the data is storing, okay, how many files it will create, in which file the data will be resides. We'll discuss a lot. Any questions? Now you can tell whether I need to stop the session. Can I continue? Because first,
Yeah, you can
on
continue, sir.
first day itself I cannot, sorry, in first day itself I cannot load everything. Okay, so because this is the as a DBA, everyone must and should know about the core concept. Everyone must also, because when you are trying to attend any interviews, so they may stress a lot on the core concepts. Even you having 10 years experience, 12 years experience, they will stress on this core concept only. What how the processing is happening internally. Okay, can I continue? Can I stop?
You can continue, sir.
Yeah, I can just continue this page. Okay, uh, tomorrow we'll start the page architecture, because it may take lot time, so I need to explain the complete the page architecture, then different types of pages. Okay, let me first discuss the what's happening when you create a database. Okay, see, when you create a database, SQL Server will create two files by default for you. When you create any database, SQL Server will create two files by default. That is one MDF, one LDF, master data file, or you can call it as a primary data file. You can call it any name, sir. Either you can call it as a master data file, or you can call it as a primary data file. And one more is log data file, LDF. Okay, so that is what here I mentioned, transaction service. Okay, why I'm not explaining, because you need to know about the LDF. So we have separate session for LDF architecture. Okay, we'll discuss a lot about log file. There is no much need to be discussed on data file. Simply it will store the data. Your data will be residing on MDF, master data file. Your whatever the data you are processing, right? Like whether you are inserting whatever the data you are updating, you are deleting, right? Everything will be physically stored in the master data file. So this is how your data file looks like, master. Let me go you and show you the sample how it will looks like. First time whoever seeing. Okay, let me go to, okay, so this is how your data files and log files will be looks like. So okay, when you create any database, every database by default it will create two files. One is primary data file, that you can technically call it as a master data file, and one more is transaction log file. Physically your data will be residing on the primary data files. So whatever you are performing, insert, update, delete, create, okay, that will be physically residing in these files. Okay, so then what is the log file, sir? Everyone will have one question. What is log file? Change related. Okay, whatever you are performing changes, see, you cannot directly go and perform any changes on primary data file directly. Every changes, so for example, you are inserting, you are updating, you are deleting, every changes need to come from the log file to the data file. That need to be changed, need to be come from the log file to the data file. We cannot directly perform any changes over the primary data file. Okay, so primary data file contains the actual data. You directly, we are not authorized to perform any changes directly on the primary data file. Every changes whatever you are performing, that need to be come from the through log file, transaction log file, LDF. All change related information will be logged under log file in a simple term. Got you? Got you, online people? Okay, so when you create any database, sir, okay, when you create any database, it will create by default two files. One is master data file, one is log data file. Okay, so one more file you can create, that is NDF, secondary data file. You can create a number of secondary data file. You can create a number of log files as well. In one database, sir, we can create a number of files, sir. Yes, sir, you can create a number of files. But by default, it will create 2 files. But you can create a number of data files, a number of log files in one database. Okay, so you can create a number of NDFs, secondary data file. NDF stands for secondary data file. This is how it will looks like, sir. Sorry. Okay, so your secondary data file also, see here the secondary data file, primary data file, secondary data file, log file. See, you can create a number of secondary data file. Because, sir, why you need to create NDFs? So for example, your database is terabytes. Okay, if you are placing everything in one file, what will happen, sir? It will impact the performance, right? Yes or no? Yes or no? It will impact the performance, right? Okay, to improve the performance. Okay, to improve the performance, we'll create a number of secondary file where we can divide the data into the multiple files. Instead of keeping everything in one data file, you can keep data in secondary data file, so that it will also improve the performance of your request. Okay, your data, when you create a database, it will create 2 files by default. One is primary data file, one is secondary log file. You can create a number of secondary data file. Okay, so that is happening. So when you create a normal database in the SQL server. So that is what I explained, so simple. Okay, primary data file contains the start of information. Yes.
So you mean to say primary data group having all the dictionary data, and secondary means you are creating another file group to store the user data.
No, not like that. You can keep user data as well in primary, sir. But
That's okay.
primary
But
contains, yeah.
The
Sorry,
main I was like, what is the main purpose of the secondary data?
that is what. If we want to improve the performance of database, instead of keeping everything in one file, see, take one Excel, sir. Take one Excel sheet. Okay, you try to insert 10 lakhs records in one Excel, and you try to insert few more 10 lakhs in same Excel sheet. What will happen when you are opening, when you are saving, when you are updating? It will take some time, right? If you are keeping multiple Excel file and keeping 10 lakhs records in one Excel sheet, 10 lakhs records in one more Excel sheet, it will improve the performance, right? Like same
Yes.
in SQL Server also, you can create multiple data files to improve the process performance of your request, instead of getting the data in single file.
Okay.
Okay, and the primary data file will contain the startup information, sir. When you are starting your database, so all the startup information will be available in the primary database. That technical you can call it as a boot page. Boot page will be available only on the MDF, sir. It won't be available in the NDFs. Boot page. Okay, it is the 9th page. I will discuss a lot about tomorrow. Boot page. What is boot page? Boot page will contains the metadata related to your database. Metadata means automatically it is updating to a boot page. That boot page will be available only on the primary data file. Okay, clear?
Yeah, clear.
Okay, let me pass.
I have only